Hi, Social Work 351. This is James again, having fun making these videos. Last night we had tinkered a bit with the descriptive statistics, and then at the end of class we talked about this process of computing the standard deviation. And we have it in our textbook. I believe it's on page 40 if I remember correctly. And what I wanted to do is to use this apartment temp data again to actually use Google Sheets to help us compute the standard deviation one step at a time. And more specifically, we actually have two standard deviations. And I won't actually do this yet, but if I start to type in ST for standard deviation, we have a few of these different options here. And the two that we are going to be interested in is this STDEVP, standard deviation of an entire population. Our textbook refers to that as a biased standard deviation. And then we would also have STDEVA for standard deviation of a sample. Actually, I'm sorry. STDEV, standard deviation, because we're only dealing with the numbers here. So that's the standard deviation of a sample. These are the two that we're going to work with, and so we're going to compute them with using columns B, C, and maybe D of this sheet. And we're going to compare these values to what we get with these formulas. We're also going to compare those with this standard deviation that we get from our descriptive statistics. So we're going to tie all those together. Last night we talked about the concept of standard deviation. Standard means typical or average, and deviation means difference. So really we're asking the question, what's the typical different distance from the mean for our data set? Okay? Well, we've got the minimum and the maximum. I can type in a formula. This is going to be the mean. I'm just giving a label here. I'm going to hit equal sign for formula. Now, the way that Microsoft Excel and Google Sheets deals with the mean, they actually call it the average, which would be nice if they called it the mean. But it's the average, the arithmetic average. And so we want the average, again, from cell A2 to A26. I'm going to use a closed parentheses to tell Microsoft Excel that my function's done. When I hit enter, again, there's our mean of 70. And that's the value we're going to use as our reference. So we're asking the question, how far is 72 from our mean, which is 70? And actually, instead of typing in the 72, if I click on this, it brings up A2, the value that's in A2, and I'm going to take away our average, which is 70. Okay. Well, I can ask, how far is 71, or the value from A3? How far is that from our mean? And that's going to give us the 1. Nice thing about Microsoft Excel is we can do copy and paste. If I copy, so if I come here, and if I'm on a Macintosh, I'll do Command C. If I'm on a PC, I will use hold Control, and then push C. When I do that, it copies the formula. And when I paste, it actually updates the formula for each one of these cells. So if I come over here and click on this, this is the value of A4 minus 70. This is A5 minus 70. If I come down here, it's A15 minus our average, or our arithmetic average, our mean of 70. So these are all of our differences. We're asking the question, what's the average distance? We could just take the average of this, but we've got positive and negative numbers. In a standard deviation, we get rid of that by generating squares. In mathematics, a square is just taking a number and multiplying it by itself. B2 if I hold the shift key and the number 6 becomes this caret, and if I type in a 2, that means B2 times B2, or B2 squared. I can do the same thing with the next value. We're squaring these differences to make them all positive. There are some additional benefits, but I'm not going to cover those additional benefits to squaring in this video. I'm going to copy and paste. Again, I'm copying this formula. It does it automatically. When I paste, now I see I've got B13 squared, B18 squared. And if you look at these values, they're telling us that the difference is 0 because the value is the same as our mean. So there's no difference for that particular data value. So we've got our differences and we've squared them. Now what we need to do is we want to find this average. Okay? So to do our average, we need to add up. This is the sum of the squares. So we want the sum from the square column. And I'm going to type in this SUM. We're going to add up all the values from C2 up to C26. And that gives us 112. Now we want the average of this, so we need to divide. Now here's the trick. So we've got the sum of squares, and if we want to move towards the standard deviation of a population, if we were treating this as a population, that would be the 25 data values. So we could take the 112 and divide it by 25. Now that gives us a 4.48. And recall that we had done the squaring. So to get the standard deviation of the population, we have to take the square root of this population value here. So the square root is, you might remember as squirt. It kind of looks like the word squirt, or square root, SQRT. And we want the square root of this value. Okay, so the standard deviation of our population is this value right here. Now, for a sample, instead of dividing by the 25, we're dividing by 24. That's that degrees of freedom. So it gives us a slightly different value than the 4.48. And to get the standard deviation of the sample, we're again, since we've squared these values here, we need to take a square root. Equals the square root function of this 4.66 repeating. So now we have the standard deviation of the population and the standard deviation of the sample. So I want you, in 10 seconds, I want you to pause the video and see which of these, the standard deviation of the population, standard deviation of the sample, which one of those matches the value from our descriptive statistics. Pause the video. Well, now I'm trusting that you've paused the video and you went over to our column or our set of descriptive statistics. If you see this standard deviation here, the 2.1602, that's the same as the standard deviation of the sample. So what that tells us is when Microsoft Excel in the descriptive statistics generates a standard deviation, it's doing the standard deviation of the sample. And that is the typical way to go. Very rarely do we do a standard deviation of a population when we're collecting statistics. There are cases where we would, but for the majority of the time, we don't. So we have these values. Now, you may have also noticed this sample, this is actually the sample variance, which is, it's also known as, it's the square of our standard deviation, because the standard deviation is the square root of the sample variance. So this sample is actually the sample variance. And this population up here is actually the population variance. Variance is another measure of spread, very strongly tied to the standard deviation. But for a lot of what we report in this class, we're going to be relying pretty heavily on the standard deviation. So they're kind of giving us the same information presented in a slightly different way. Okay, so we've got the standard deviation of a population. We're going to test that out here because there is a function, as I said earlier, the standard deviation, but we want this population, standard deviation of an entire population. So if I select this, let's see here, my first value is 72, my last value is 70. You'll see that this 2.166 is exactly the same as the standard deviation of the population. Standard deviation, okay, let's do this. Okay. And that's if we were treating this apartment temperatures as our entire population. But as I said at the beginning of the first video, this is a sample of data, so it would be more appropriate to talk about standard deviation of a sample. There is a pre-built function for standard deviation. It's actually just standard deviation, STDEV. Standard deviation of a sample for this sample of data, again, gives us the 2.16024, so on and so forth. So there we have it. We can generate the standard deviation of a sample in the descriptive statistics. I demonstrated how we can use differences and squares to sort of manually compute the standard deviation, both of a population and of a sample. And then I showed the pre-built functions in Excel or Google Sheets to compute the standard deviation of a population for a set of data or the standard deviation for a sample set of data. So there we have it, standard deviation from a data set in really 3 different ways.